Good afternoon, everybody. Welcome back, and thanks for joining us again this afternoon. We're here today to obviously dive a little bit deeper into the world of ADAS calibrations, and today hopefully we can show you a bit more about the influence of different repair methods and different areas of calibration. So with me today, obviously I'm Jason Land. We've got downstairs in the calibration room, we've got Igor Pole, we've got Tony Richards, and we've got joining us today Yoris Sanders. So thanks, gentlemen, for joining us. And like I say, we're here today to sort of, again, very, very informative, very, very interactive. We'd love to answer your questions. We'd love to be able to try and dispel some of those myths and hopefully really just give you some good value. So please make use of that chat box, 5 questions away. Really more than happy to try and talk to those. So like I said, we've got a couple of calibrations to show you and sort of just provide some feedback on what things can influence the calibration and can provide us with an incorrect calibration or even a false positive calibration. So behind us, you'll see that we've got our Texa RCCS platform set up. Today, we're looking at the front of a 2018 Mercedes X-Class Ute. So Igor, I think you're going to talk to us a bit more about the sensor we're going to calibrate, and yeah, let's see where we go.
Thank you, Jason. Welcome, everybody. And let's share screen and talk a little bit more on that vehicle that we have here in the bay. So what you will see now, let's see, takes a little bit of time to load that picture. So what you see is that front, we have a front radar, and that radar, it's made by Continental IRS 410. You can see here these panels, which Tony holding in the hand. That radar, it was in production from 2017. It's very relevant for what we have on the roads today. A little bit on specification side, a very advanced unit, how it was advertised back then. If we're looking into the specs, we can see that there will be 3 different range, field of view, very long 4 degree, short 45 and mid 9 degree. Also, if we're looking a little bit on resolution, we see horizontal 0.2 degree here and vertical 1.5. You'll see later where that can start to be important. Range, it's 170 meters. So I will stop sharing from this point. That screen, maybe Tony can say like a little bit about the panels that we will put in front, and then we can move live from the vehicle.
So what we're going to do, we've got a bit of a setup here. Just I'll jump in and quickly talk to this. So we've got the vehicle set up, we've got the calibration set up exactly how we would normally calibrate a vehicle of this sort with that platform. Usually we would have the front bumper in place. So normally in front of this radar is either a plastic insert in a bumper cover, or potentially a badge, a vehicle badge. So what we're just demonstrating is just the different influences that could be had when we're repairing these vehicles compared to an OEM panel. So we've got a bunch of panels, and the first one we've got is an OEM bumper. It's just a cutout of an OEM bumper. We put it onto a stand with a what are we doing there, Igor? There we go.
Yeah, this is original bumper here on this vehicle. So just to share that, so that will be original state of the vehicle.
Yeah. Cool. So so we've got a stand with a PVC pipe, and we're going to just drop in some cutouts of bumper panels in front of the radar and just see the influence. So obviously, right now we can calibrate that. If we switch to the Texa.
Yep. Just a second. We're moving live.
Cool. So we're connected to the vehicle now, live into the OBD port and through to the front radar calibration. And what we can do now, with the platform set up to the OEM measurements, it's in the right place. So we can probably perform the calibration, and I would expect that should go pretty well. So if we can just click through to that. And
almost there. We're going live in the system. We can see here the state of angles like before we start. Vehicle is calibrated on this 2.0 and 2.1 degree. And Tony, we are ready here, so whatever you're ready. Jason, we're going with the first panel. Can you tell?
This panel, yep. So this is a cutout of an OEM bumper. So it's an absolute just rolled off the factory floor. We've cut it out, factory refinish. About 90 micron is the coverage on there, on the paint coverage. So I would expect that it should have pretty straightforward calibration. So we'll click through and.
So calibration in a progress system calibrated, give the information that the horizontal angle is 195, vertical 151.
So both well within spec.
Yeah,
that would be a successful calibration.
Yeah, and that will change here. All right, Tony, are we ready with the maybe second panel? Can you, Jason?
So the next panel, it's the same as before. It's an OEM bumper, but it's got some superficial damage, so you can't see from here, obviously. But there's a few cuts in the panel. We've done it obviously with a grinder and made some just some slots in the panel to see what influence that might have. So again, let's just proceed and then see what the influence was. Remembering that we had 1.95 degrees and 1.5 degrees in the last calibration.
So we have successful calibration here with this panel. Even the panel, it's damaged, so that definitely wouldn't be true positive result. There will be the fake positive. Can be maybe with another panel.
Yep. So if we go through the next panel, it's an OEM bumper and it's unfinished. So it's had damage. It's had some traditional repair with the body filler. And like I say, it's unfinished, so it's just open flesh wound that's been filled like a traditional repair method would be before it's refinished. Let's see what influence that has.
We have calibration in progress. We have change of angle here on 2.1175. Still successful. Can we turn the panel opposite, Tony, please? And we will try one more time with the panel on the other side.
So we're just rotating that 180 degrees, Igor?
Yes, correct. We're rotating the same panel 180 degrees just to see the influence of the repair on the angle. We have calibration in progress. Angle change again here. We have it, I think, different on a vertical this time, 0.23. Yours, can you remember maybe previous one or? That was fast. All right, we're going a bit fast here. So
so that was so we've had quite a swing and change. So the initial one with nothing with the factory finish was about 1.5 degrees on the vertical. So we swayed up to about 1.75, and now we swayed back down to 0.23 just by rotating that 180 degrees that same panel with the traditional repair method. So there is influence there. Obviously, they're achieving a calibration within the window. But yeah, let's push on and see what else. So the next step we're going to,
panel.
The next panel. So the next one is it's refinished. So it's that same panel we've had with the traditional repair. We've now refinished that. So it's got 2 coats of medium solid primer. It's got 3 coats of the base coat and then 2 coats of clear. And as you can see now, it's actually stepped outside of the target or the calibration window for the vertical angle, and we're now up at 4.5 degrees. So the influence that amount of filler, primer, base coat, clear coat has significantly changed the ability to recalibrate that sensor and achieve a result.
All right. Tony, it's helping and putting the panel now, which have the vinyl wrap there, I think.
So the next one is, again, back to an OEM bumper, not refinished, not repaired, just as it comes off the factory line, but it's covered with a traditional, like a vinyl wrap when people sign write cars. So again, let's see what the influence is. And remembering back to the original panel that was not just plain refinish was about 1.5 degrees on horizontal. We're quite a long way different to that now. We can see the influence is probably 0.75 of a degree in the measured value back on that radar. So quite a significant influence.
All right. So we are ready to put the last panel there.
Last one. So this one is again OEM bumper, no damage, no repair, traditional, just as it is. but we've got a vehicle chip protection, so those clear films that are put on for paint protection on the front of vehicles. So let's see what influence this has.
So as we said before, this is the latest generation of the radar, very capable. So they can kind of manage some of these challenges. But there will be no question here, what is actually the true calibration? What's the true angle? Or, is it, if it's failed, like you have it in one case, do we really need to do the adjustment, and what will be the right one? So Tony, would you like to join us here and maybe make a comment on I'll stop sharing and make comment what we actually have and what we saw. And
the last one also failed.
The last one was passed, yeah, the calibration was successful. The calibration which failed was the one where we had the OEM repair traditional method and then painted, which we know it's not correct calibration, because you cannot repair the bumper in an area where you have that radar. So technically, it's
so
not
I think
correct.
we can all agree on the fact that every single different material in front of that has given us a different result, which obviously leads us to a conclusion that anything that is put in front of the space in front of a radar, whether it's a front radar, whether it's a blind spot radar, can only be the OEM designed material, a brand new OEM bumper, refinished to the same specifications as OEM, which I think mentioned earlier is around that 90 microns. Otherwise, the influence is made, and we can't be confident to say that is a correct calibration. Although it's within the window, we just still can't be sure at different angles how the radar receives back, signals are received back. So yeah, I think that sort of certainly creates more questions than it does answers, I believe. But I think the only answer is obviously OEM.
What we can also demonstrate with this system, when they, latest generation, you can actually achieve these false positives even without using platform. So that would be maybe interesting to see, can we actually calibrate that, get that false positive result even without the platform in the front.
So if you could tell us, Igor, just a little bit more about the material. So it'd be actually really cool if we could probably just swing the RCC towards the camera, Tony, just so we can show the people on live with us today what the target is in front of that. It's a rectangular matter. There we go. So that rectangle platform there. How would you describe that, Igor? What's that composed of?
Calibration plate, we can also use the trihedral elements on some Japanese cars, which we will see later on. But yeah, we have that calibration plate which bouncing the beam.
So those plates are designed to be obviously at the right distance from the vehicle, the square to the vehicle, hence the targets we've got all set in the right place, which was all pre-done, obviously. But what that does is it sends a signal out, it rebounds it off that plate, and the plate is generally a fixed plate at 0 degrees. Some different vehicles require a forward and a backwards angle change during the calibration process, but this one was just a straight 0 degrees, shoot out, reflect back. Thanks, boys. So I think we just talked about we're going to take the gear off and maybe just roll that vehicle forward and just see what happens when we try to calibrate it with no platform in front of it. It's going to be pretty interesting to see the result here, I think.
Absolutely. So
I'm anticipating, I know you guys have had some trial runs, but I haven't been privy, so I'm anticipating what's going to happen here. It'll be quite interesting.
So what I will do, I will share the screen again so we can follow up the work of Joris and Tony from the another screen.
While we're just waiting for the boys to roll the vehicle forward, no one's got any questions so far or comment. Please don't be shy. We'd be more than happy to talk to them. No questions, a silly question.
All right, so we have a vehicle toward the wall here.
How far away are we from the wall there, Igor? We've got a distance that we've kind of predetermined.
We are approximately 1200.
Okay, cool.
Okay.
So we've got the vehicle parked 1200 away from a concrete wall. So just straight into a concrete wall. Obviously, Igor's going to launch the calibration, and we'll wait with bated breath to see what might happen.
That's definitely false positive. we managed to fake, the system obviously, and get some angles which are in this plus minus 3 degree, that definitely you wouldn't consider this as a result that you will give as a proof to the insurance company for sure. So can we move it a little bit forward? A little bit, make the gap bigger, maybe, Tony? Yeah. All right, let's try one more time and see how far away actually we can fake the system. It's still calibrating, so can we move it a little bit, more? Let's try one more time. Of course, these results will depend, are we really straight to the wall or are we have some angle? And definitely here we can see this result 0-0 actually. Finally, system failed, so that's not an angle. That's just the result when the system fails. So definitely we have a failed calibration here. And if we're looking into the system here, we'll see that system is not calibrated and we'll have the fault which is active now. Fault will be on a dash. And if we release the vehicle back to the traffic, absolutely, system wouldn't work. But in some of these cases before, as you acknowledge, unfortunately, driver will be heavily misled with some of these calibration results, which didn't actually, we definitely cannot call them true positive.
Yeah, and I think that's for us, it raises concerns around making sure that these calibrations are done in a credible way, in a way that can be audited, or a way that can be proven that it was done by the correct equipment. Because while that's achieved a successful calibration on paper, it's definitely what we term in our organisation as a false positive, because we know that it's not an accurate positive calibration. It's just and as that goes down the road, it might be the fact that as the vehicle's driving down the road, it will try and they do try and sort of self-line as they drive, or they at least check as they drive. And we can't tell you how long that's going to last before that. We'll drive down the road and we'll determine that it's not working correctly, and in fact it's not calibrated, and a fault light might come on. And that could be anything from a few Ks to potentially 20 or 30 Ks or 100 Ks before it actually then self-checks itself and realises that it is not a true, accurate calibration that was performed. And then you might see a fault light. But there's a lot of time driving where we just don't know that that's accurate. Now, the boys have slightly rotated the camera. We've got another vehicle in there, so it's a later. Is that a 2020?
2019, I believe. 2019, yeah, Toyota.
What, a CHR?
Yes, correct.
So this is a rear blind spot, and for us, there's a lot of prerequisites before we can go and do a calibration, and one big one that we are well aware of is space, and the free open space in an area to perform a calibration. So in this particular one, we've gone through can you show us that, Edgar? I think we're just going to reconnect it. So sorry, I'll stop jumping the gun. But when we go through the process and log into the vehicle and go through the setup instructions on how to calibrate a vehicle, it'll show us. Let's wait for that to log in. Here we go. It'll show us the space required. Obviously, not also where the target needs to be and the distance to the target and the angle to the target, but also the free space required behind this target to achieve a successful calibration. And all these instructions are all done on OEM data, so they're pulled from the OEM information.
Yes.
We'll just get into that now. So if you scroll down, it tells us the equipment we need, all the little prerequisites, and right there it shows us the space required to perform that calibration accurately. And as you can see, that's 10 meters from the center of the vehicle backwards, 8 meters from the bumper back, and a total of 9 meters in width, 6 meters clear to the side of the vehicle of clear space. So that's quite a large area.
Should we engage a little bit the audience and see, if they can recognize some objects there, in space?
Absolutely, it'd be interesting to know who can spot what. Obviously that's quite a large space, and it's hard to tell from the camera angle. But I bet you there's some things in that area that probably the space isn't right. Who's got any ideas out there? What do we got?
Do we have some response?
No, we've got no takers in the comments. So this one's
Okay. I think that garbage bin is a bit shy there, so maybe it's not that much in space there. If we don't have a comments, maybe we can continue with the.
Yeah, there's no one's game enough to stick their hand up, mate. So carry on, and then maybe you just tell us what in that space. Obviously, this is for test purposes only. So go through and then maybe sort of point out a few of the things that aren't quite true and correct.
Right. Sharing soon. There. So, but Toyota system here, it's offering us to actually read the angle before we calibrate it, and that's also, it's another challenge because gives opportunity for even more options to fake the result, because we can actually see where we are, and then we can kind of adjust position in a space which wouldn't be OEM compliant, and then we can just print that out later. Result, which will be in that particular tolerances for the system. So what we have now, we have that cone, which is on the in a position which is OEM compliant. We see that angle there; it's minus 0.13 degree. If we see on a right side, what we see that the angle is in between minus 3.6 and 3.6 plus, that will be successful calibration. So if we just go back from this and perform the calibration, then we'll get that result on a screen. So should we, Tony, maybe introduce some maybe that move that maybe bin and see how that will influence our radar. So we have.
So James, I'm just going to jump in there, Eagle. So James has just said that it should see the ute in the background, which is absolutely accurate. That ute is well within the space required for a clean calibration. So even though it's detected only a 0.13 degrees variance of where the radar's directed, I suspect that if we did it again with that radar, with that ute out of the space, which unfortunately we probably don't have time to completely shuffle the shop down there to make that happen, but it would be a different reading. So this is purely just to demonstrate what influence bringing things into that area do. So I see we've moved that bin in there. I see there's a little steel object sticking out of it. So let's just to perform a read and see how different that is. So all we've done is just rolled that wheelie bin into the space occupied between the blind spot radar and the calibration target, the trahedral element cone. So it's only just moving into the space, into the thing. So let's put it right in the middle. Let's put it right between, in the way.
Put it a little bit on the side there. So it's actually not in a way, but it will be a little bit side there. So it's still.
Let's see how that works. So it's probably in line with the how far outside the vehicle that cone is, and just slightly behind the bumper. So be very interesting to see what influence that has in our reading.
So definitely change of 0.3 there. So now it's 0.44.
Yep. So and this is only a plastic bin with a little steel stalk inside it. It's like a little piece of 40mm box section or something. So it's not a great chunk of steel. What else we got down that we can put in there? It's a little bit bigger that might have a maybe could influence it even more. What do we got there?
So Tony was prepared something which is typical in mechanical shop. There is a small gearbox hoist. So we can put it, so it's around, I'll say 1.5 meter away over middle to the center line.
Directly on the vehicle. Yeah?
Yeah.
Okay. Let's see what happens.
I forget the last, what was minus
0.44 was the.
So minus now 0.28, again, yep. Change, in a space. And that will depend, of course, about the generation of the vehicle. Here we have kind of latest vehicles, so they're still we can still influence these vehicles, and the results, there we can move it on.
What we could see there is potentially the radar, the trahedral element, the target that we're shooting at could be in the wrong space, but the influence of other material in the area could then obviously give us a calibration result that's not accurate.
Yes, or it's false positive, if we have just the trahedral element and the calibration should fail, something else actually will influence that result actually become false positive.
Absolutely.
So bigger concern. We see here now bigger influence, like, on a different position.
And obviously, again, that's a relatively small item, and still having a degree and a bit of influence over the received signal back. So it's quite a sizable amount. You can only imagine putting a hoist in the space or something that's of significant size against a wall that's only not far away. And there's so many things with steel reinforcing the concrete or something. So there's lots of things that will definitely create a larger influence, but that just shows that there's pretty susceptible to stuff if we haven't got the clear space that we and that's why manufacturers make those recommendations of space.
So how are we going with the questions from the audience?
Quite audience today. We haven't got a lot of questions yet. Is there anybody that does have questions around that? Obviously, that's kind of wraps up the two things we're going to demonstrate. Anything we want to sort of elaborate on that, or any questions around that, or want us to show something else that might be helpful? So James is just, would those things show up in a cross-traffic alert function as well?
In a way, like, that this object which we're putting in, like, will show up in a as a cross-traffic alert. So yes, but radar needs to be calibrated properly to be actually able to calculate these angles, like, of the coming traffic sideways. And if the basic calibration, what we're doing, it's not correct, if the angles are not set properly, then everything else what the system will calculate will absolutely be wrong. And the alerts can come, too late, or not even be, on time, or not even happen, depending what is the offset. We was with the small elements here, we was just getting the small differences. You can imagine that there are quite a lot of other influences which can significantly move that angle maybe closer toward these edges, to the 3 degree or 3.6. Absolutely.
Cool. Hopefully that answers that, James. So I've just got a question that's been pointed out. It's come through on an email through the MailChimp for the invite. But what parts of mechanical servicing need to be checked and reset by ADAS? It's a very, very good question. So obviously you talked to that, Igor. So what parts of mechanical servicing need to be checked and reset by ADAS?
Okay, so I guess
Joris is very competent on this. I will skip this.
Perfect. Thanks, boys.
Okay, so for example, mechanical servicing. So doing a cam belt or a timing chain job on a late model Audi. You've got to put the whole front of the car into a service position, moving the bumper, etc. So in that situation, the front radar would most definitely need to be recalibrated to ensure that it's 100% correct. Another example,
Suspension work, maybe.
Yeah, suspension work. So if or even tire, if someone's changed the tire sizes, gone to put some aftermarket rims on with different size tires to the OEM, then certainly recalibration will be required. That's it.
Tony, from the mechanical point, what else can be standard? Ring, suspension, fronts.
So I think a big thing, obviously, and when we again we refer to OEM manuals and OEM procedures, that if a sensor has been removed or refitted, or the object or the material in front of the sensor has been moved and refitted, so i.e. bumper covers, or you've had to take the complete front off, like you're said, to access timing chains and the like. OEM practice and OEM instruction is to recalibrate that sensor. So yeah, that's a pretty big question, James, and definitely an answer that's a lot around awareness. But there's a big problem with a lot of people who haven't had to consider that in the past. Have just done the job and put it back together and make sure everything goes and there's no fault light and off you go. But obviously going into the future, these systems are with us now, and we're doing these jobs, and the calibration is required by the OEM practice.
A little bit more on the electrical side, like, changes component like the steering clock, the steering sensors, yaw rate sensors that will also trigger sometimes OEMs to demand that procedure for the calibration of the radar sensor.
Yeah, most certainly. And again, back to we spoke last week about that sensor fusion and the when the sensors are all operating together, and it's not just the camera and the radar, it's the G sensor and the yaw rate sensor and the steering angle sensor. They're all part of the stability and the controls around autonomous braking, and they all integrate together. They all communicate. They've all got different protocol and hierarchy and what takes over. But again, all the sensors need to work in cohesion to make sure that those systems work properly. So yeah, very, very good question, James. Anything else? Any other questions? Let's must be lots of things out there with people wanting to know more about. What do we got?
So just shortly back to audience, which was with us last time, we shared some problems with the Ford Transit with the windscreen and aftermarket glass, where we was not 100% sure is it aftermarket glass. There was a small heater net in front of the camera lens. We can confirm that today our partner there in Motueka confirmed that after installation of the OEM glass, autonomous emergency braking functions are working normally. There is no message on it there, so that's good to go on the road right now.
Nice. And thanks for following up on the Eagle. That's great. It's good to put a full stop on some questions and actually get a conclusive answer. So that's really, really good. James Brown has just asked us, after a wheel alignment, does it require a calibration or a recalibration?
Yeah, absolutely.
Yeah.
Everything which will I can share from screen, one slide which is on the camera side, but the same thing here with the radar. We have this horizontal, vertical angles. This one pointing. I'll just wait a little bit. So why these alignments are important is that let's wait until we get a screen. I should work now. Stop sharing. It's just it's slow.
We're good. Yep.
So our sensor here, we can see actually camera have some position, and absolutely we're living in a 3D world which have his own coordinates, and then that alignments and they're quite different alignments on the camera sensor. We have even internal alignments when they producing these sensors, so they aligning internally that lens toward the sensor there. So technically, calibration procedure just bringing and aligning that position of that sensor to the 3D world, because then calculation will work properly. We can share even here. We have another slide which we can go here just shortly. Just a second.
Yeah, I think an easy way to try and break that down break all those squiggly lines down and straight lines down into thing is that it kind of the reset is putting it back into its for lack of a better term, its zero position in the 3D world. It puts it back to its alignment of its zero or center calibration set point.
Yeah. Yes, absolutely. If it's not correct, in how it's designed by OEM, then all of these higher levels, of acting on data analysis, will just be completely executed wrongly, and that doesn't work. And it can have significant consequence, absolutely, to the if you're talking about autonomous emergency braking.
Right, I'm just waiting to see any more chat questions pop through. I can't see any of yet. Again, don't be shy, guys, out there. If there's questions you wanted answers for, or you came on to find out more information about, we're happy to tailor this session. Like I said, it's pretty interactive. We didn't want to just speak for an hour or so of the stuff that you didn't want to know about. We're more than happy to tailor the conversation towards your questions.
One more information we came, which is like following up on the previous session last week, was regarding that LiDAR sensor that we have on Mazda. So even the vehicle was Japanese import, we was trying to find the correct OEM informations, and we have some which are very similar vehicle with a similar sensor. Information about the distance, we discussed a little bit the distance from for that LiDAR sensor there. OEM information was showing that sensor is capable to detect objects only to the 6 meter, which is really not a long distance.
No, so I think from memory, it was a really, really narrow for the guys that joined us last week. when Tony stepped across the front of that vehicle, the focus on that LiDAR sensor was a very narrow beam, and like you just found out within a bit of research and got the actual answer that it's only looking 6 meters. So absolutely only in city traffic operation, short start stop control. Yeah, but that will still have an influence. Obviously, the long range radar will be watching up the road, and then this will be a confirmation that we are getting pretty close to an object.
Do we have any question on this subject?
Questions, Igor. So, why don't you pull up some of your other slides, and should we just rock through some other stuff that's certainly
well
important.
One of the things which is kind of put it on the side when we're talking about ADAS. Usually, if you join different videos on YouTube, you will always see the talks about the front radar and blind spots and the camera system. But some kind of cameras which are involved with the 360 system, they always stay a little bit on the side, and would be actually good if somebody here maybe pick it up that Mercedes there was on the slide which we share. I'll just reshare it again. There was a 360 camera on that bumper, and if we can rescan it, maybe Tony, if we can bring it back, scan it to our to our Mercedes vehicles, then we can show something here. So as we share a little bit, that's the original bumper, which will have that plastic cover, and then what we see here is that front camera lens. So that Mercedes X-Class also have a 360 system. That's also important for the insurance companies when you have a very simple repair, when you actually maybe don't change nothing with that plastic, you still in this case you actually touch the ADAS system, and what you will see now, what we will share, we will rescan the vehicle again, and you will see that there will be a fault here related with that 360, and that 360 calibration also will need to be performed.
That calibration, Igor, that obviously that comprises of the camera at the front by the center of the vehicle there, and obviously there's some other cameras around the vehicle, so I would assume there's a couple one in each mirror, the wing mirrors or the side view mirrors, and potentially one at the back as well. Is that correct?
Yeah, Tony's performing a visual check, and yeah, we can confirm. Yeah, Tony, we have it on the website. Yeah. Yeah, we have front screen camera, we have a cameras on the mirrors, camera on the back.
Okay.
So definitely system
uses all of those cameras to stitch together a nice image of the 360 degree.
Yeah. Our device was a little bit slower. It's a big metal panel. It's a decent vehicle, so Bluetooth is a bit slow. We're getting there, so we'll just see now we'll scan at least. We talk about collision diagnostic last time bit. Maybe if there is interest there in audience, we can point to a few things here toward that side, and let's go then first and perform that fast diagnostic assessment for this vehicle. So we see here on the add for keeping lane that actually he had that radar sensor adjustment that was changed. There was a fault there on C code. Then we again on transmission, even transmission complaining that inclination sensor, which is radar sensor, actually have malfunction. So the transmission also getting some informations and monitoring our system. And then parking gate camera 360 system. As you can see it now, we are here. It actually said there is a front camera generic electric failure, absolutely, because it's unplugged. And we also have here on the left mirror video camera, we have a fault there. So I'm not sure only what repair was done here. Did it was involved anything on the left mirror or on this vehicle? So what is
this? It's just a square frontal collision on this particular vehicle.
Okay, so obviously nothing involved.
Headlight replacement does have extra headlights in it, which will need to be reinitiated.
Okay. So part of collision diagnostic will be understanding, which faults here actually related with the accident which happened, and which faults are maybe something which was in a system before, which maybe it's not then wouldn't be covered by the insurance by that event. But definitely, like I said before, we have that front camera here, missing calibration, and we also see, of course, on parking system that we have open circuits again. Bumper is still not installed, so we have that fault there active, isn't it? Do we have further questions in from audience?
No, we don't. But I guess that just puts a full stop on the point that the pre-scan before any work's carried out is very, very important to just understand what conditions are, like you say, impact damage or collision related, and which might be pre-existing conditions that were already a problem before we've done any work, before the repairers have done any work. So again, it just emphasises that the importance of that whole end-to-end process.
Yeah. But one of the things which is important to uncover these potential problems down the track. At this moment, we can assume that vehicles still have significant value, so it wouldn't be written off just because of a few additional faults which will be discovered down the track. But the idea is that you get that fastest early enough, because sometimes you can do some repair when the vehicle actually it's not finalized, it's not like detailed and ready to go to the to be delivered to the client. Some of the experience which we have from Australia is that lots of times happen on a Friday 4 p.m. There's lots of stress and people expecting just calibration and then they are programming of the electric power steering module which was installed just last minute in, and that significantly then change customer satisfaction if you bring already client pick up the vehicle and then you need to give them bad news that you cannot actually finish the job on time.
Absolutely. Yeah, very good point.
So how have we been time?
We're pushing up on 45 minutes. So I think we've covered what we wanted to cover today. We did have a bit of time set aside for questions. So again, feel free to fire those questions through. At this stage, there's not many more questions. It might be a time for us to wrap up and
well, this session will be recorded, will be shared as a recording, so we can maybe add a few things now to address some typical questions which we usually have so I don't know.
Yeah, feel free. I think if you've got some things in your head that you get asked frequently, let's just pop through those and again if it raises more questions, feel free to chip in. Absolutely.
Well, one of the question is from insurance point always what we don't know that we don't know, and we kind of start to categorize this risk in categories. So we have we allocate 6 different categories, and we can share that slide, that information, and then there are quite other subcategories which we can talk about more in a private session. So I will use the opportunity maybe to talk about that. Also, if you are in a business, so you're planning to go in a calibration business, or joining ADAS experts, or trying to do it for yourself, just to be a bit more aware, where the risks are, what you can actually, what can be the concern, and so we see here first absolutely. Risk and categories around these technologies now. So because when you're servicing vehicle, if you're just normal general mechanic, now you need to deal with that additional layer of safety system, active safety system, which needs to be, addressed or service it properly. And maybe, as you already said, when you're doing the timing chain, now you actually suddenly can become liable for the autonomous emergency braking performance, isn't it?
Absolutely. So, we need to make sure that it's being done in those situations.
Yeah.
So, you've got no risk there.
Yeah, absolutely. Yeah. And it brings additional, that significant cost now into that repair, which is traditional repair. I mean, people kind of having idea what the timing belt replacement can cost, but is it the same?
Well, there's obviously additional calibration of the front radar in this instance, and even the camera potentially.
Yeah, if it's like 3-4 years system, and you have aftermarket glass, and then you cannot be sure how it's done before if somebody achieved that false positive result. That's the challenge. So these are risks around these technologies. I mean, there are quite more. For each category, we have a lot of subcategories. Then risk around the software, hardware, equipment used for recalibration, and we actually didn't talk about that today much. We are aware of a lot of these. So if you have some equipment which is aftermarket equipment, but it's not OEM compliant, then performing calibration with that equipment or instructions which are not OEM equivalent, then you can put something which is not OEM equal, and then you can maybe get that again false positive result.
Yeah.
For false positive, we shared the slide last time, but these are actually our major concern, because you really don't want to mislead nobody, not mislead yourself. So you're really trying to emphasize on that.
Absolutely. James, sorry, I'll just jump in there. James just put a question through. I just want to jump onto it. He's just asking, what is the current warrant of fitness and insurance requirements for having ADAS working?
Well, I think you guys can talk a bit more on that because you're more up to date what's happening in that field. So
I guess currently NZTA have not included any ADAS requirements in the VIRM, the Vehicle Inspection Requirement Manual. There is work being done in the background to start looking at issues around that. So things like chips in the windscreen around the camera certainly going to be an issue moving forward. Also, when you've got warning lights on the dash. So at the moment, the only reason the car can fail its warrant is for airbag, ABS, or traction control lights on the dash. Really now, if any of these ADAS systems have got a malfunction and there's a warning on the dash, that should certainly be picked up and knocked out for warrant fitness. But it's currently not in the manual, so technicians or warrant inspectors can't fail it.
Yeah, and I think there's definitely an evolving situation, and I know recently we've had the update to the LVVTA when they're complying a vehicle that now, if we're in even, I think, entry compliance now, if there is a fault on that, needs to be addressed and a repair needs to be made, the calibration needs to be made and declaration performed, but not currently as a warrant of fitness requirement. And just to talk to the insurance requirements a little bit. So there is a requirement for the vehicle to be returned to the customer or to the end client in a condition that is equal to or better than before the impact or the occurrence or what's happened to trigger that insurance claim. So there is a requirement for them to have these systems put back to how they were before, and obviously we know through a lot of testing and research that a small impact can certainly have an influence or manipulate that calibration or move that sensor. So they definitely require part of it, a calibration as part of that repair. Absolutely. Hopefully that answers that, James. Hopefully that sort of covers what you were getting at there.
One challenge for sure will be how the warranty fitness inspector then looking in that panel that Tony present to us, which is look like, from visual point looks okay, how then, that can be addressed, that there was actually repair, which shouldn't be done on that particular, area where the radar is behind, especially on the blind spot side. So that's a massive challenge. But where there are challenges, there are solutions for sure. So maybe point a few more here on that side, just to share, and that we get that better awareness, what can really happen. So today was a lot of talk. Earlier presentation was on that space requirement, which is absolutely critical for the systems. We just waiting for the slide here back again. We point that we demonstrate that even on the latest generation of the vehicle, that's still that still is concern. And of course, it's getting worse when you have something which is 7-8 years old. It's not great. Let's see here what's happening with our slide.
We're back.
Oh yeah, we're back. And then one thing which was barely touched last time, I think there was a question, non-OEM in second-hand parts, like, use it for this, system. So how that will then, affect the performance and what kind of risk that introduced. That was a great comment.
Yeah, so on the radars, so it quite clearly states on the back of the radars that if they're dropped, that they're no longer to be used. So, in that case, how do you know whether that radar sensor has been dropped between the time that it's been pulled off the dismantled car to the time you fit it to the car you're working on? So there's no real, I don't think there's any possibility of using a second-hand radars in this instance.
No, and it's an interesting point that it says, because we've got one actually here we could have could share, but it says if this unit is dropped, and I'm pretty sure that dropping that unit could be equal to a significant accident and impact. I wouldn't see there being any difference. So, yeah, absolutely, you'd be very, very cautious of, and obviously a best practice would be not to use second-hand components, I would suggest.
A little bit back to the collision diagnostics. So let's see that we had that last time, that Mazda, and we have that front impact, and the radar was still communicating up to the point when you repair the vehicle back and try calibration. You actually wouldn't understand if the calibration will be successful, if the radar, maybe have internal damage, because lots of these antennas are very sensitive internally, and they can be moved, and then, if you have a vehicle, this is where the collision diagnostic and what Tony tried to achieve here in our program is that we don't get to the stage when then additional cost of that replacement of that radar will actually tip off the value of the vehicle that will actually be, written off. So you technically put some time, put some parts, and then adding this component now, the vehicle actually needs to be written off. So I think it's another.
It's really important that right up front, that a really accurate diagnostic process is used so that the vehicle is diagnosed as accurately as possible, without obviously knowing what the electronic component's condition is. But if it is, any indication in the diagnostic report, then that can be taken into the scope of works and what repairs will be required.
Absolutely.
Just showed this here on 6. I mean, there was a questions today around that other companies and technicians who are repairing, servicing, modifying other vehicle system or components which are connected or related to the performance, like wheel alignments and tire change. I think that's a whole new field which needs to be addressed, the whole new education awareness layer which somebody needs to put out, and it would be great to see industry to joining into that, and the government, maybe to really start pointing that out.
I think it's a lot around awareness, and there's just not enough awareness around this topic. And people just aren't aware. They just don't know what they don't know.
Yeah. We have a great slide on that too, but we shared a few times more before.
Excellent. Hey, we're pushing up now on sort of 55 minutes, and nearly the hour we'd set aside. There we go. James, perfect timing. Would the radar control come up as faulty in its own diagnostics as something that should show up as inoperable or replace? Igor?
Yeah, look, it can, or it may not always. So
speak from your personal experience in the vehicle that you drive. I think that's the best. Yeah, let's do that.
I was thinking more about the other Audi there. So
okay.
The one.
Sure,
okay, so we had an Audi A6 at work that it's the blind spot monitoring was not working. So talking about a rear radar or blind spot monitoring radar. And in that situation, there was a fault code log for the master or right-hand side control module was faulty. So we ordered a new module or a new radar module. We fitted it. We went through the calibration process. The right-hand module that we replaced, because it passed the calibration. Then as part of that process, you can't just calibrate one radar. You've got to calibrate both radars on the rear. So we went through the process, calibrated the left radar. The left radar would not achieve calibration. It would only go up to 70%. So we ended up having to replace the left radar as well. So that was, in that case, the fault report only had a fault log for the right-hand side radar, but once we actually went to launch the calibration process, we ended up having to replace both rear radars. That car's back on the road now.
Yeah, and car was previously back on the road and still didn't pick it up, like the fault. We have a very good on. I was last year in CX-30, brand new Mazda, where the radar was collision repair. It didn't have the instructions, and they just fit it opposite, like 180. And the vehicle was 4 days on the road before actually first fault came in, and then was investigation and repair. So yeah, unfortunately, you will expect that they will be built smart, but you can see that 2017, very advanced radar, I wouldn't recognize that actually calibrating on the wall, that there is actually bigger space than that square, rectangular plate, which shouldn't happen. Let's say it like that.
Yeah. So I think to answer your question in short, obviously if it's had a significant impact and it's had physical damage and components inside have been damaged, you would expect to see a fault code, but the answer is not always, I would say.
Yeah.
It does present some challenges.
Absolutely. One thing is maybe to share also is like we performing test drives of performance of the system. We're not just performing the pre-scan and repair and calibration of the sensor. We're also going for the test drive to confirm that the system is operational. Unfortunately, you cannot go in a traffic in a way that you will be able to test all the functions or that you see completely the performance. And when we have case like this, where the panel was maybe repaired traditionally, where it shouldn't be, maybe that system will need a longer distance outside of the town drive when the system start to calculate on the longer distance, and then maybe we'll came with a fault, but you cannot do that if we try to offer our partners economical solution. We cannot go for the drive a few hours outside of town. It's just not viable, unfortunately. So that's another challenge for the industry, how to deal with that.
All right, guys, we're nearly smack on an hour, so that's been a really good session. Thank you, everybody, for participating. Great to have some questions. Great that we'd hopefully answer them for you. And as always, we're all ears. If you've got questions, please do reach out outside of this webinar. We've find our website, find our contact details there. You can reach out directly to myself, Igor, Tony, Yoris. We're all available to help. So yeah, thank you again for joining us. Really appreciate your time. Hopefully it's been insightful. Hopefully you've taken something away. And we really look forward to bringing you some more useful information in the very near future. Thank you, everybody. Have a great afternoon.
Thank you.
Thank you, everybody.
Cheers.
Enjoy.